depend on the first action, or the 1,000 percepts down the line can depend on the first action. So we make no Markov assumptions or anything like that. And that's important because this is how the real world works. If I say dig down a treasure in my backyard today, then I'm going to find it if I dig 10 years later. So it's like the real world is not Markov, and this is reflected in our formulas. Just to compare this a little bit to the MDP framework, which is the standard basis of traditional reinforcement learning. In this framework, agents transition between states by taking actions. And the environment specifies, given a state and an action, which new state will you be in, S prime, and which reward will you get on the way there. And the policy is just a map in which state you take which action. The history framework is actually a lot more general. So just to compare the two, for histories, we have the percept that we see every time step, and in the state-based MDP framework, we have a state and a reward that we see every time step. It's easy to see that histories are at least as general, because we could just let the percept E be a state and a reward. But we can have the percept be many other things, so histories are much more general. In particular, it's easy to have hidden states with histories. There's nothing that says that this percept that the agent sees at time step reveals everything about the hidden state, or about the state. We could do the same thing with MDPs, and then we get OMDPs, which is sort of like a more complicated version of MDPs. Histories also allows us to have worlds with an infinite number of states, like the real world has an infinite number of states. And this is something that's typically never considered in the standard reinforcement learning framework. Environments can also be non-stationary, and this means, for example, if I'm in a self-driving car and I make a sharp wheel turn in summer and good road conditions, then I'm going to turn the car. But if I do the same thing in winter and there's like super road conditions, then the result will be something completely different. So the result of an action might be different at different time steps. And this is sort of automatically allowed for this environment's view. It's just a distribution that depends on the entire class. But which is a little bit harder to incorporate in the MDP framework. It can be done, but it's just like an additional complexity. Finally, an agent can just be defined as a policy when using histories, but in MDPs, an agent must be defined as a sequence of policies in order to incorporate learning. So for example, the agent would start with the random policy, and then as it gains more experience, the policy would change in order to be more directed to rewards. But when using histories, all the information the agent has is encoded in the history, so the policy itself can be learned, which is just nice notation. And all this generality comes to price. It makes learning a little bit harder. In an MDP, such as this one, you can just return to the same state an infinite number of times, and after you've been in the state many times, you will know how this state works. When we're using histories, you never know if you return to the same state. Just see longer and longer histories, so there's no returning to the same thing. So learning needs to be much more sophisticated. You might think it's actually impossible, but it's not. And that's one of the amazing things with this theory. It tells us how to learn despite this super general setup. So that's the next topic, learning. How to learn in this super general framework.
You can probably
so the agent, you think of it as a
working
newborn baby. It just can take
necessarily
actions
the
and
center,
kind of sets a return. And from this
incredible
direction
technology
needs to figure out some structure of the
you
world.
get these pieces together and they work pretty well as a system. Once you put only like 2/3 of those pieces together, you just
and of course it's important that the agent can learn, because it must learn in order to be able to predict consequences of its action, and it must predict in order to be able to plan, and it must plan in order to act intelligently. So like learning is this crucial first step, right? learn the true environment from interacting with someone. The true environment is